Right, the answers to Monday's problems. There's 6 problems on Monday. I'm not going to go through all 6, but regardless, if you haven't done the work from Monday yet, please don't watch this video. It's not going to do you any good if you know the answers already when you go to do the work. You got to try and do the problems first, and then you can use this to check your work. So, please turn off the video now if you haven't done the problems yet, and if you have, here we go. First one, number 47, was y equals x squared plus 4x minus 1. Now, what I wanted you to do were to find 4 points and then plot those 4 points and connect them to make a parabola. So, one of the 4 points was the y-intercept. I started with that because that's the easy one. That's just -1. Remember, that's the number, that's the constant, the number that doesn't have a variable by it, the number that's by itself. So -1 is the y-intercept. Now the x-intercepts, there's going to be 2 of those. That's going to cross the x-axis twice on most of these. So you can't factor this nicely. The x-intercepts are not integers. They're not whole numbers in this one. So you either have to complete the square or do the -b plus or minus the square root, all that, the quadratic formula. I chose to complete the square for 2 reasons. One is a is 1, there's no number in front of x squared, and b is an even number. Whenever you have that situation where a is 1 and b is an even number, it's, I think, a lot easier to complete the square. So to complete the square, we need to take half of b and square it. That's going to be our c term. So half of b is 2, and 2 squared is 4. So we need this to be plus 4, not -1. So how do we get that to be plus 4? We add 5 to it. -1 plus 5 is positive 4, plus 4. But if you add something to one side of the equation, you have to add the same thing to the other side. So that's what this first line is here. I wrote down the equation, x squared plus 4x minus 1, and then added 5 to both sides of the equation. So -1 plus 5 is 4. So that's what my next line is. I've got my x squared plus 4x plus 4 now is equal to 5. And now you can factor x squared plus 4x plus 4 because 2 is the number that multiplies and adds. Multiplies 2 times 2 to give c and add 2 plus 2 to give b. So it's x plus 2 times x plus 2, which is x plus 2 squared. And that's the whole point of completing the square, is to factor it, and you're using that same number. Now you can take the square root of both sides, and the square root of 5 is positive or negative square root of 5. And now you are almost done. All you have to do is subtract x to the other side. Or I'm sorry, 2 to the other side to get x by itself. So you have -2 plus or minus the square root of 5. So this is where you have to use a calculator to estimate the square root of 5, which is 2.23. So we basically have -2 plus 2.23 or -2 minus 2.23. So if it's -2 plus 2.23, then it's just 0.23 is your answer. And if it's -2 minus 2.23, it's -4.23. So those are my x-intercepts. So those are the 3 points that I found so far, and I've plotted those for you. Right there, 0, -1, that's your y-intercept. -4.23 is just a little bit to the left of -4, and 0.23 is a little bit to the right of the origin. 0.23, not even to 1. So those are my 3 points. The equation is positive. A is positive, so it's going to open up. So my vertex is going to be down in this area somewhere. So that's what I'm going to do last here, is find the vertex for you. Which you find the x-coordinate of the vertex by doing -b over 2a. So it's -4 over 2, which is -2. So I know I'm going to go, that's my axis of symmetry. My vertex is going to be on the axis of symmetry, so it's going to be over to -2 and then down. So it's below -2 down here somewhere. And to figure out how far down it is, you substitute -2 into the original equation to get what your y-coordinate is. Y is going to be equal to whatever you get. So that's what I did here. -2 squared instead of x squared. 4 times -2 instead of 4 times x minus 1. So you get 4 minus 8 minus 1, which is -4 minus 1, -5. So my vertex is at -2, -5, which is down there at the bottom of the slate. Now you connect your 4 points that you plotted, and there's your parabola. It's a beautiful thing. All right, that one was a little bit tricky. Most of you probably did not use completing the square method, which is fine. You can use the quadratic formula. Some of you might even be using Desmos.com and just clicking on the points, and there'll be these two numbers right there. So however you did it, hopefully your graph looks like that. All right, number 48 was negative 3x squared plus 6x plus 9. Again, the y-intercept is the easy one. That's 9, the number by itself, the c value. The x-intercept, to find the x-intercept, I'm actually going to factor on this one. So when you factor, this is probably something I haven't gone over with you yet, is that you want a to be 1, just like with completing the square. So we don't want this to be negative 3, we want it to be 1. So why am I going to factor? Because I can pull a negative 3 out of each one of these terms. Negative 3 goes into 6 and 9. So if I pull a negative 3 out, then it's x squared minus 2x minus 3. I factored out a negative 3. See, if I distributed that negative 3 through, I'd be right back to where I started. Now, x squared minus 2x minus 3, there are two numbers that multiply to give negative 3 and add to give negative 2, and that's negative 3 and positive 1. Now you might think, all right, that's fine, but how do you take this line now that we have a negative 3 in there and find your x-intercepts? Well, remember I told you to find the x-intercepts from factoring, only one of the parentheses has to equal 0 because 0 times anything is 0. Well, now we have three things being multiplied together. We have the negative 3 times the first parenthesis times the second parenthesis, and that logic still holds. You could have 100 things being multiplied together. If one of them is 0, your answer is 0. So as long as one of these parentheses is going to be equal to 0, then this whole side is going to be equal to 0, and that's what we want. So it's still the same method. It's what do you put into the first parenthesis to get it to be equal to 0? You put in a 3. And what do you put in the second one? You put in a negative 1. So I've plotted those 3 points so far. 0, or no, I haven't. I only plotted the vertex and the y-intercept. Oh no, sorry, I did plot them. All right, so 0, 9 is our y-intercept. 3 zeros right here, that's one x-intercept, and negative 1, 0 is right there. So notice, well, let me do the vertex first. All right, you substitute into the formula and you get negative 6 over negative 6, which is positive 1. Now, what I was going to tell you is that the vertex is always going to be exactly in between your x-intercepts because the vertex is on the axis of symmetry. It's symmetrical. So your x-intercepts are always going to be the same distance away from the axis of symmetry, or else your parabola wouldn't be symmetrical. So what is in between negative 1 and 3? Positive 1. Positive 1 is 2 spaces away from negative 1 and 2 spaces away from 3. So you really didn't even have to do all this to get x is equal to 1. You could have just looked at your x-intercepts and said, what number is in between negative 1 and 3? It's positive 1, so I know my x value for my vertex is going to be positive 1. So that's kind of a little bit of a shortcut there. If you do your x-intercepts first, you can find the point that's in between them, and that's the x-coordinate of your vertex. Now, there is no shortcut for finding the y-coordinate. You have to substitute in a 1 into your equation, but luckily 1 is an easy number to work with. So it's just negative 3 plus 6 plus 9, which is positive 12. So your vertex is all the way up at 112. And then you connect your points. It opens down because we had a negative 3 for A, and it'll look like that. So when you guys graph these, you don't have to put 12 tick marks and get it exactly. You can just draw your parabola and label the points like I'm doing here. And that's it. All right, let me do one more for you because problems, the last 3 problems were similar in the fact that the C value is 0 on all of them. There was no C on all of those. So that means our y-intercept is going to be the origin. So the 3 parabolas for the last 3 problems are all going to go right through the origin at some point. Well, I don't have my book open, so I don't know what the problems are. So I think that's a good enough hint. On the last 3 problems, your y-intercept is 0, and when you go to find the vertex, that only uses B and A, so you don't even need a C. And when you go to find the x-intercepts, if you're using the you're not going to be able to factor it, so you're probably going to use the quadratic formula. If it works out where A is 1 and B is even, then it's pretty easy to use complete the square. But if you're using quadratic formula, you do use C in that equation. That's inside the parentheses. It's B squared minus 4AC, and 4AC is going to be 0, because anything times 0 is 0. So it's really just B squared is inside your parenthesis. So you square B, inside your square root, and then you unsquare it, because it's inside of a square root. So it's really just negative B plus or minus B over 2A for your vertex. So the last three problems are actually doing you a favor. When there is no C, it makes a lot of things go away, and it makes your math a lot easier to do. So I think you guys will be able to do those three pretty easily. I did the two hardest ones for you. If you're struggling on them, just send me an email and I'll help you out with them.